The human population. We are finally here to some very controversial topics. The human population size, affluence, resource consumption, they all are interrelated and they all impact the environment. Probably one of the best examples that most of my students know is China. China is striking with more than 1.3 billion people. That's almost 20% of all humans live in China. All right, fertility and total fertility rate. So to understand more about the role that births play in population growth, demographers look at what we call the TFR, the total fertility rate. And that's an estimate of the average number of children that each woman in a population will bear throughout her childbearing years. So, for example, the United States, the TFR was 1.9. That's a mean or an average. Obviously, you cannot have 0.9 children, but each woman of childbearing age gave birth to just under 2 children. Unlike the crude birth rate and the crude death rate, TFR is not calculated per 1,000 people, but instead it's a measurement of births per actual human woman. So to gauge changes in population size, demographers also calculate replacement level fertility. The TFR required to offset the average number of deaths in a population so that the current population size remains stable. So typically, replacement level fertility is just over 2 children, right? Because they have to account for the loss of that. So 2 children replace the parents who continue to have more children, and when the parents die. So replacement level fertility is higher than 2. But however, because it is also, you must account for children who die, they're able to have children, or some people cannot have children, all that other stuff. Then we need to basically use something else. So the rate of death among children depends on a country's economic status, and they factor that in too. So in developed countries where there are relatively high levels of industrialization and lots of income, we typically see a replacement level fertility of about 2. In developed countries who's got relatively low industrialization, less income, very poor countries, we typically see a TFR greater than 2.1 is needed to achieve a replacement level of poor countries. So replacement level fertility is higher in developing nations because the mortality of children tends to also be higher. So demographers project that the human population will be between 8.1 billion and 9.6 billion by 2050. So by 2100, I was just so far away, I know I won't see that number. It is projected to be between 6.8 billion and 10.5 billion. So the dashed lines are in this diagram, they are estimated values because the fertility rate and the replacement level and pollution, all of these things are going to factor into how our population is going to change over time. Our life expectancy is changing. Speaking of life expectancy, so to understand more about outputs in human population systems, demographers study the human life span. Life expectancy is an average number of years that an infant born in a particular year and in a particular country, and how long they're expected to live. So given the current average lifespan and death rates in a country, life expectancy can generally be higher in countries that have better health care. And life expectancy also tends to be a good predictor of the high resource consumption rates and also environmental impacts. Life expectancy is often reported in 3 different ways. The overall population of a country for males only and for females only. So let me give you an example of these 3 different ways that we can report it. In 2014, global life expectancy was 70 years old overall, 68 years for men and 72 years for women. In the United States, the life expectancy was 76 years overall, 73 years for men and 81 years for women. So in general, human males have a higher death rate than human females, leading to a shorter lifespan. Here you can see the life expectancy and how it varies quite significantly actually by continent to continent, and in some ways country to even country. So even where things are bordered, amazingly enough, the life expectancy is very different just right across borders. Infant and child mortality, I think, are relative to healthcare. So the availability of healthcare and access to good nutrition, and also exposure to certain pollutants, all of these factor into a life expectancy, infant mortality, and child mortality. So the infant mortality rate is defined as the number of deaths of children that are under 1 year of age. So they are not really considered a live birth until they're at a year age. The child mortality rate is defined as the number of deaths of children age 5 and under per 1,000 live births. Actually, both of these are per 1,000 live births. So this figure shows the infant mortality rates around the world. Just soak it in for a minute and just feel how lucky you are, and as a girl, as a woman, as a mother, soak it all in. It's quite surreal, like when you look at it across a map, and hopefully it makes sense to you, and you can see how lucky we are based on just where you were born. Aging and disease is, of course, something we need to talk about here. Even with a high life expectancy and a low infant mortality rate, a country may still have a high crude death rate. And that is in part because a large number of people are older. So in the United States, for example, we have a high standard of living, more so than in Mexico, which is consistent with a higher life expectancy and lower infant mortality rate. But at the same time, the United States has a much higher crude death rate at 8 deaths per 1,000 people on average. And that's quite a bit more than Mexico, which is only 5 deaths per 1,000 people on average. So this higher crude death rate results from the much larger elderly population that's in the United States. With 13% of us being at age 65 or older, I'm not included in that, but compared to in Mexico, where only 6% of the population is older than or 65 or older. And disease is an important regulator in human populations. According to the WHO, what we call the World Health Organization, infectious disease, those things, disease caused by like microbes that are like transmittable from one person to another, are the second biggest killer worldwide after heart disease. And in the past, like things like tuberculosis and malaria were two of the infectious diseases that were responsible for the greatest number of deaths. But today, human immunodeficiency virus, also known as HIV, which is cause for concern, which turns into an acquired immune deficiency syndrome, also known as AIDS. These are responsible for more deaths annually than anything that tuberculosis or malaria could have ever have done. So between like 1990 and 2012, AIDS-related illnesses killed more than 28 million adults and children. Because HIV is disproportionately affects infants aged 15 to like 49. So the effect on adults and the effect on infants is quite different. It's not a disease that specifically targets an age group. The most productive years in a person's lifespan with HIV has a more disruptive effect on society than any other illness that can affect either the young and the old. And for that reason, because of the age difference, it affects more than just one factor. It affects birth rate, death rate, and all of those things combined. And even though as Americans we oftentimes see AIDS as an adult disease, HIV has a significant effect on infant mortality, children mortality, and population growth, and overall life expectancy. So in southern Africa, 23% of the adult population is infected with HIV. And so their life expectancy fell from 63 years to about 40 years of age, just from the 90s to like around 2009, 2010. And it's been increasing slowly, but it's not, back up to age 63 where it was when I graduated from high school. So this figure shows approximately 34 million people were living with HIV in 2011, and 22 million of them in sub-Saharan Africa. So it's where the greater population is. The annual number of deaths due to AIDS peaked at about 2.1 million in 2005, and it's decreased, since then. We'll talk more about AIDS and stuff. We actually do a whole unit on, part of a unit on infectious disease. All right, so regardless of birth, death, disease, any of that, a country may experience a population growth like steadily or declining as a result of migration. So we call that the net migration rate, and that is the difference between immigration and immigration. This is also another number that is a given per year per 1,000 people of any given country. So a positive net migration rate means that there are more immigration than immigration. And a negative net migration rate means that the opposite. More people are leaving versus those that are coming in. So let me give you an example. Approximately 1 million people immigrated to the United States every year. It's a pretty traditional thing. And only a small number immigrate out. So with the U.S. population being 315 million, these rates are equal to 3.2 immigrants per 1,000 people. A country with a relatively low crude birth rate but a high immigration rate may still experience population growth.